We use the power rule of integration when trying to find the original function of its derivative. To find the function, we have the function of u raised to the power of n plus 1 over the same value of n plus 1 plus the constant. In our first example, we have the integral of 4x plus 3, which was derived with respect to x. The first step is to look at each term separately. So first we have 4x dx plus 3 dx. This separates the problem and makes it easier for integrating. Our next step is to factor out the coefficient in each integrand. This leaves us with 4x d of x plus 3 dx. From here we look at our x's. First of all, we have x to the power of 1, and then we have the second x to the power of 0, which is also equivalent to 1. From here we straighten out our integral signs. So now we have 4 with our x to the power of 1 going to x to the power of 2 because of the rule where we add 1 to the exponent over the same value of 2, plus our second part of 3, and then x to the 1 adding to the 0 over the same value of 1. Then we also have to add our constant value because when the derivative was taken, the constant would have gone to 0. This is used for indefinite functions. Finally, we simplify. From here we can see that the 4 with the x squared over the 2 becomes 2x squared, and our 3x1 over 1 becomes 3x. And we also make sure to add our constant, which is unknown because of the given information. This concludes the first example. For our second example, we are trying to find the integral of 1 plus 2x minus 4x to the power of 3, which was derived from x. Now we look at each term separately. So we see that our integral of 1 is 1 d of x, plus our integral of the 2 of x, which the x is to the power of 1, and lastly, the integral of 4x cubed. Now we integrate each term, so our 1 dx becomes x plus 2x squared because we add the exponents together and divide by that same value. And our 4x cubed becomes 4x to the power of 4 over 4, and again adding our constant. Finally, we simplify. This becomes x plus x squared minus x to the power of 4 plus c. In our last example, we're looking at the integral of 3x minus 2 over the square root of x derived from the variable x. We can rewrite this as the integral of 3x minus 2 over x to the power of 1/2. Unlike with the previous examples, we can't break up the entire term to 3x dx minus 2 dx because it's all one function altogether. Because of this, we can also use algebra to break up the function instead. When we use algebra to break up the terms, we now have 3x over x to the power of 1/2 minus the 2 over the same x to the power of 1/2. We can simplify this further to make it 3x to the power of 1/2 minus 2x to the power of negative 1/2, because when we brought up the x variable, our power becomes negative. From here we integrate. So our 3x to the power of 1/2 now becomes 3x to the power of 3/2, because when we add 1 to 1/2 we get 3/2, and we divide it by the same value. Same with our 2x to the negative 1/2. When we add 1 it becomes 2x 1/2 over 1/2 plus our constant. Finally we simplify, and our end result is 2x to the power of 3/2 minus 4x to the power of 1/2 plus our constant. In conclusion, our power rule of integration is used when reversing the operation to find the original function. In other words, we are taking the derivative and reversing that process.